An epoch is one full pass through all the training examples. We run this for many, many epochs.
Hoping to stop when the network's outputs match the targets and the weight changes, the delta zones are basically zero.
Right. And with the complex nonlinear MLPs, while convergence is generally guaranteed mathematically, finding the best solution often comes down to tuning the practical parameters.
And there's no more critical parameter to tune than the learning rate, eta. This is the tightrope walk of optimization.
Why is it so hard to pick the right ETA?
Because the optimal value is so dependent on the specific problem, the dataset size, the network architecture. You have to experiment wildly. Values can go from 1.0 all the way down to 0.0001.
And the choice is constrained by two opposing catastrophic scenarios.
Right. Scenario 1, eta is too small.
The slow crawl.
The slow crawl that never ends. If the learning rate is minuscule, the network takes these tiny baby steps across the error landscape. Convergence takes an extraordinarily long time, potentially days or weeks longer than it needs to.
In a business sense, you're just burning computing cycles.
Exactly. Scenario 2. ETA is too large. This is the more immediate catastrophe.
Okay.
If the step size is too big, the weight updates will overshoot the error minimum. Imagine standing in a small valley and trying to take a step toward the bottom, but your stride is so large, you leap completely over the minimum and end up halfway up the next mountain.
The weights just diverge, bouncing all over the place, and the error goes up instead of down.
It can explode, the algorithm just fails entirely.
So you need that sweet spot. Large enough for efficient progress, but small enough to settle into the minimum.
Absolutely. And the activation function choice also plays into this. We noted that tanh is antisymmetric, while the standard sigmoid isn't. Using an antisymmetric function often leads to faster convergence because the derivatives are generally larger, letting the error signal propagate more effectively.